First thing I wanted to do was make this visible in the editor. So let's go to the script. And let's change this to @tool, but I want this to run in the editor. All this can run in the editor. The process, we want this to be if not engine, that is editor hint. No. Tab. Right, so this will not run in the editor. And then we can put the @tool up here. @tool. Okay, and then if we go back here, I think that I would see this being 4, no? Do I have to run it once maybe? No. This script is currently running in the editor. So if this is being run in the editor, then why don't I see it in the editor? Why don't I see the changes I made? I'm just for like 2. And back to 4. Well, let's do 3. Okay, so I see it there, but I don't see it being changed in the editor. And the @tool annotation to existing script editor does not automatically restart the underlying execution thread for that node until a reload event occurs. Reload the scene. Click scene in the top menu and select reload saved scene. Reload saved scene. Oh, okay. There we go. Now I see it in the editor. Okay. So I just have to reload the saved scene. Noted. But this will not run in the editor, right? If not, entry.isEditor hint. returns true if the script is currently running inside the editor. Otherwise returns false. This is used for @tool scripts. You can initially draw editor helpers, prevent accidentally running game code that would affect the scene state while in the editor. Wait. How do I make it so just this code, or this code is not running? The script run in the editor and other code not run in the editor and Godot. When specific parts of a script inside the Godot editor while keeping other parts restricted to live gameplay, you must use the @tool annotation combined with edgen.isEditor hint. Adding the @tool forces the script to run in the editor as well, and engine.isEditor hint allows you to separate the behaviors. Okay. Use the engine.isEditor hint conditional check to selectively run or block your logic. Func process. This block only runs in the Godot editor. Okay. This block runs only during actual gameplay, if not engine.isEditor hint. Okay, so I did that right. Yeah. Okay. Okay, all good there. Alright, so I think that's good. Let's start working on the swinging rope, so the horizontal rope. Oh, wait. I needed to do one more thing with the vertical rope. I also need to call this vert climbing rope. Let's rename this to vert, or climbing rope vert. I want to rename the scene to climbing rope vert. Do I need to delete it here? Climbing rope vert. Okay. There we go. Okay. Now I should be able to instantiate climbing rope vert, right? Let's move this over here. Move it up a little bit. Move it like that. And then we'll make this a 3. Run it. sure it works. And then we need to scene, reload, save scene. There we go. Now we can see it. Okay. And then one more thing, this knot. I want to make sure this knot is, wait, what the? Why is the collision shape way down there? Whoa. Okay, so I need a node reference to the knot. And I want this knot to also be added to the very end. So originally it's at Y4. I need to set its position to that times the amount of ropes, right? So like if I had 2 ropes, then I need to send this position to 8. So we'll do just at the very end, climbing rope not thick, dot position dot y times equals the what rope count? Yeah, rope count. Rope count. Okay, and then that should put it up at the top. Alright, so there should be a knot at the top. And then if I comment that out, it'll go away, right? Oops. Why is it, wait, what the, why is this collision shape getting messed up? Oh, wait. Is it being multiplied every time I load the scene because it's an add tool? Crap. Okay, you know what? I'm not gonna worry about the add tool right now. I'm gonna get rid of this, so I don't run into that issue right now. I can look at that later. Let's just go here. Let's get rid of this. Bring all this back. Save that. I don't know what this issue is. Needs to be back to 4. Position.y. I can just do times equal here, right? Times equals rope count times equals rope count. That'll do the same thing. Okay. Yes, so we have a knot at the top. Cool. Okay, I think I'm ready to make the horizontal climbing rope. So let's make another scene. This will be called Climbing Rope Horizontal. And this also needs to have, though not, it needs to have an area, collision shape, basically all of this. So we'll copy all this, paste it in here. Except here, everything needs to be rotated. So is fine there. The knot. Let's bring this back here. The collision shape. Reset that. The ropes is not transformed. This is also not transformed. Okay. Alright, so this we need to basically just, I guess we could rotate this whole node maybe. Wait, I want it to rotate it on the X. Or I want to rotate on the Z. I want to rotate on the Z. On the Z, 90 degrees. Negative 90 degrees. There we go. So it's facing to the right. And then the climbing rope knot. This also needs to be rotated. Negative 90 on the Z. And then also translated along the X-axis 4. So, okay. Save this in scenes, objects, climbing rope hors, or horizontal. We need to attach a script to it. In scripts. Objects, climbing rope horizontal. This script, I need to rename. To climbing rope vert. There. What's wrong here? I can clear that. Alright. Where's the script? Okay. The collision shape. Let's bring that back here. We want it on the x-axis too, not the y-axis. Capsule shape and rotated negative 90. Okay. Radius of 1, height of 4. Perfect. And it's basically going to be the same thing. As the vertical. So here we need the on body entered signal. And body exited. And I can go over here and pretty much copy most of these. Oh my gosh, what is going on? Horizontal, here we go. Maybe I should just modify this script since it's going to be exactly the same. That might be a better idea. Like in this script, I can just say another exported variable. If horizontal, it rotates. And then I can mess with the at tool. Because here, what I did, let's see what I did exactly. Climbing rope not was transformed the X and the Z. No, I feel like that's gonna complicate things. Let's just make a new scene. So here, horizontal, we needed signals. Like this, and connect this. Okay. And then we need pretty much all this into the horizontal. Alright, everything's named the same. Collision shape, ropes, climbing rope not thick. Are in range. I'm just gonna have to change some things in here. And also here, let's copy this over. So okay. Alright, so what I want to happen here is if we are in range, grab we're gonna have to have a different function called grab horizontal rope. On ready, we need I'm gonna X out of this just so I'm not confused. Rope mesh, rope socket, child. Okay, var count int equals 1. While count is less than rope count, so same thing there. Var new rope, rope mesh dot duplicate, ropes to add child, new rope dot position dot x, right? Dot position dot x. You need to go on the x-axis. Position dot x. Oh no, because it's rotated. So I guess that would still be y. Okay, so it's still gonna be y. Because we just rotated the whole node here. Then that means the collision shape would also be the same if I just rotated this 90 degrees. Oh, it's going to do that though. Okay, so this needs to be rotated negative 90 degrees. Then this height, okay, the height is fine. The position x, okay, so this one needs to change to position x. The position dot x times row count. The height is fine. Not position dot x also. But all this can stay the same because we rotated this. Yeah. Okay. Alright, let me go to main. Let's add a horizontal rope. Let's make this a 3 and see if everything I did works. Yes. Although there's no way I can I'm not going to be able to check the collision shape. Until I set up the new function. Actually, I can check it. Yeah, okay. Collision shape is also working as well. Alright, so I should not be able to get it on the edges. I have to go here to get it. Yeah, okay. So the collision shape did change like I wanted it to. Okay, now we just gotta set up the animations. So back in here, we need to do global.grab horizontal rope. Horizontal rope. And we send in the global position. Of the entire rope. Okay. So now in player, we need a function for horizontal rope. Func grab horizontal rope with rope position, which is also going to be a vector 3. Pass for now. We'll also have a function to jump off of horizontal rope. Func jump off horizontal rope. So just like climbing, I need states for swinging. Let's go to the player node and set up those states. So we need a swing idle and a swing. Swing idle and a swing. Swing. This should be going to swing. Okay, so this will be going to the swing one on event swing. And then it should also be going to jump. To jump. To the jump state on event jump. And then swing should only go to swing idle. It's going to swing idle on event swing idle. And also to jump. So going to the jump state. On event jump. Okay. And then also in out of menu, this should be able to go to swing. To swing idle. To swing idle. Swing idle. Okay. First, in here. Right, wait, where are we? Okay, I added it up here. Yeah, state chart descend event, climb idle. Okay, yeah. So grab horizontal vote. We want to state chart, descend event, swing idle. We need a signal for swing idle and a signal for swing. Okay. Let's make the state. Let's start setting up the state. So on state entered, this is our swing idle state. We need to swing idle dot emit, and then just like the climbing one, I need to set the velocities to 0, move and slide. And then if input.isAction press left or right, we go to climb. What is jump off vert rope doing? Jump off vert rope is getting the direction. It's rotating the direction, it gives it the velocity in the direction. Okay, so I don't need to call this jump off vert rope, I can just call it jump off rope. Because this can be the same thing for horizontal. Yeah. Jump off rope. And down here we'll call this jump off rope. Jump off rope. I'm not calling that anywhere else, am I? Climbing rope. Vertical. No, I'm not calling jump off rope anywhere else. Okay, so here, basically the same thing then. On swing idle physics processing, state physics processing, here, it's pretty much the same thing here. Copy that, paste it here. Jump, jump, jump off rope. And then we can change this to left, or input the is action pressed right. State chart.send event swing. Yeah. And then the swing state is just going to have a physics processing. Swing state. So swing.emit. Swing.emit. Get the input direction, but this time it's gonna be left, right. Velocity.x, right? Yeah, velocity. Oh wait, it could be Z too. So this one's going to be a little bit more complicated. Let's just copy this for now. I can mess with the vectors later. Velocity.x. So this is left and right. Left and right. Alright, so we're emitting the signals. Let's go to our player scene and hook up the animations. So I need to add swing idle to this, and I need to add swing to it. We need a var swing idle val and a swing val. We need to connect to those signals, so global.player_node.swing idle.connect on swing idle, and global.playerNode.swing.connect on swing. Okay, swing idle. Okay, let's make those functions. Yeah. Func on swing idle. The current anim needs to be set to swing idle. And then func on swing. The current anim needs to be set to swing. Okay. We need to add the animation to the animation tree. Right here. I don't think either of them need a restart, because they're both looping. They both should be looping. Animation. This will be for swing. Where's swing? Or no, this will be for swing idle. Swing idle. Call it swing idle anim. Let's add a blend for that. Swing idle blend. Hook it up. Like so. Another animation for swing. Where's swing? There it is. Swing anim. And hook it to a blend. Swing blend. Boop, boop, boop. Okay, animation tree is hooked up. Let's do this part first. Animation tree swing idle blend amount equals swing idle val. and animation tree swing blend amount equals swing val. Update animations, and then finally we need to update the blend animations. So we need a swing idle and a swing. Alright, here we need all of this. Copy all that, put it in here, except make this a 0. And let's add swing idle val to it. Lerp f swing idle val to 1 blend speed times delta. Okay, and then swing val equals lerp f swing val to 0 blend speed times delta. Okay, copy all this, put it in here, change this to a 0 and this to a 1. Then we can copy all of this. Wait, no, just this part right here. Copy that, and we need to add it to the end of everything else. So this will be 0. Copy, paste, 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 jump, paste, paste, and paste. Okay. Okay, so the animations should work now. Listen. Okay. Yes. Okay. I think it's because they're sharing the same collision shape. No. Why did it go to climbing? These are different collision shapes. New collision shape. 1, 4. Why did it go to the climbing animation? Why is it going to climbing? That's weird. When I stop, it goes to climb idle. one's still fine, but this one's going to climb idle for some reason. Huh. They have a different script. Are they sharing the same collision shape somehow? The parameter rope position is never used in the function grab horizontal rope. Yeah, that's in here. Wait, that's oh wait. Swing state should be going to swing idle. Here we go. Swing idle. There we go. I think that's what the issue was. Yeah, okay, there we go. That's what the issue was. Okay, now I need to figure out the rotation of the player. So, in the vertical rope, we found a look target, which was the rope position dot x. Rope position dot x. Let's see. What exactly do I want to happen here? When we grab the rope, so this one works fine. When we grab the rope, we face the rope, like exactly. Right? But this one over here, when I grab the rope, where do I need the monkey to be facing? I also don't want to grab it here. I need to move it to this position, and then I need to basically look along its direction, along its length. Let's start with the position first. Just one step at a time. So here on grab horizontal rope, we need self.global position to be the rope position dot x, rope position dot z, and rope position dot y. We have a direction, minus vector 3. What is the direction doing? Self.global position minus vector 3 rope position dot x self y position dot 3 dot normalized. See what happens here. Okay, so this just goes straight to the end of the rope. I'm basically facing the same position. I need to face left or right along the rope. Wait, I want its X and Y to stay the same. Let's see. We want the X and Y of the player to stay the same. We need the height be the height of the rope with an offset. Self.global position dot y equals rope position dot y, right? Rope position dot y. So this will move us to the correct height, except I probably need an offset. Yeah. An offset of like maybe 3 meters or something like that. Minus offset. We'll change this to like what, 3? Is that too high? 2? Oh, 2.5. Yeah, we can be higher than 2.5, so maybe like 2.3. Okay, so this is how it's supposed to look. Minus 2.3, minus 2 point, maybe 3.5. Minus 2.35, okay. Okay, so that's the correct Y position. I need to get it to the correct X and Y position as well. Position.y minus offset. And then the X and Y of the player needs to be. So the Y is good, but the X and Y needs to be like the closest point because I don't want to just move it to the X and Y of the rope, or it's going to go straight to the beginning of the rope. I need the X and Y to be closer to the rope. Y is okay. But the X and Y needs to be what if I had like a raycast in here maybe? Let's see what Google says. So like, what's my question? How to move the player to the closest point, XZ point in the collision shape when the player enters the collision area. To snap a player to the closest edge of a collision shape when they enter an area, you must project their current position. Oh wait, I need to say in Godot. In Godot 3D. To move a player to the closest point of a collision shape in Godot 3D, you can extract the shape's data, Convert the player's position into local space. Utilize Godot's built-in geometry, 3D, or shape methods to find the closest point. What? A collision shape objects themselves lack a built-in get closest point method. The most reliable approach in Godot 3D is to cast a ray cast from the player's position towards the center of the area or shape and snap the player to the resulting collision point. This method is highly accurate, automatically accounts for the shape's rotation/scale, and prevents the player from getting stuck inside walls. Add a Raycast 3D node as a child of your player node. Ensure its enabled property is checked in the inspector. Attach the script to your area or collision object. On area body entered, if body equals player. var dir player.globaltransform.origin.direction to global transform. Global transform. Area. Point the recast towards the area center. Raycast.cast to direction times 10. The intersection or hit point equals raycast.conclude. Huh. It's turning out to be a lot more complicated than I thought it was going to be. I could have I need to get the ropes. What kind of methods do we have for collision shapes? About for raycasts. What if I add a raycast to this? Raycast. Wait a minute. Let's see. Let's delete that. Okay, so here, like wherever I'm at, I can find the direction, the distance from my origin, from my XZ coordinate to the rope XZ coordinate, and then that would be the hypotenuse. And then I should calculate the distance based on the angle. All right, let me get out a pen and paper. This is a good chance to try something a little different, actually. What if I get out like paint or something? So let's say we're here. We're here. The rope origin is here. So I can calculate this with distance 2, right? Like distance to function. I need to calculate, or I need to move the player Y by X. I need this coordinate point. And this would be like XZ. XZ. Let's call this Z. So I need to position the player at XZ. So if I can get distance 2, I can calculate X with, right, if this is like theta, cosine or sine X is opposite over hypotenuse, right? So sine theta is X over Z, so, or X over, we'll call this D. So D sine theta equals X, and D cosine theta equals Z, right? Because sine theta equals opposite over hypotenuse. Cosine is adjacent. Z over hypotenuse. So times D will give you that. So I need to get the angle and the distance too. There's got to be a function for that. Let me look that up really quick. Godot method to find the distance between 2 points in 3D space and the angle of the x, z coordinates to that other point. Vector 3.distance2 method for distance. For distance 0.1 distance to 0.2, so I can get the distance, find the angle and radians on the x, z plane. For direction 0.2 minus 0.1, a tan 2. Direction.x, direction.z. Hey, what's up, Daddy? What am I trying to figure out? So I'm working on I'm working on the horizontal climbing rope functionality. And it's turning out to be a little bit more complicated than the vertical one, because the climbing rope or the horizontal one can be like rotated around the y-axis, you know? It's not always going to face the x direction, it's not always going to face the y. So right now I'm just trying to get the player positioned correctly. So right now when I grab the rope, you're not really positioned correctly, see? So basically, the Y position can be the same, because like, so the rope's origin is this knot, right? The rope's origin is this knot on the very far left. That is the rope's origin. So when I interact with the rope, I can set the player's position to the Y value, so that's correct, right? I have it on at the correct height, but the X and the Z coordinate needs to be like snapped to the closest point on the rope, right? If I just set it to the rope's coordinate point, then the player's going to be snapped all the way to the back of the rope. So that's what I'm figuring out with like vectors and stuff. So, right, here's the player. Here's the rope origin. So I can use Godot's distance to function to calculate the distance, and then the x and z coordinate would be d sine theta, d cosine theta, right? Use a path 3D? What's path 3D? If horizontal, change the basis. Yeah. Take its basis that would normally be vertically and just rotate the basis so it's horizontal. I don't think that would work. Yeah, it's a little more complicated. Like, I thought it was going to be simple too, but it's different because, like, the vertical rope here, it's always going to be pointing straight up. It's always going to be pointing straight up. It's always going to be pointing along the y-axis, right? It's always going to be pointing along the y-axis. But the horizontal rope, it could point along the x-axis, it could point along the z-axis, it could be pointing somewhere in between the x and z-axis, you know? Like, it's not always going to be on the x-axis, it's not always going to be z-axis. Like, I want to be able to rotate the horizontal rope, like, all the way around the y-axis. So that's why it's a lot more complicated. But I think I'm onto something here. I want to try this out. So I can get the distance to multiply it by sine of the angle. Let's see how to get calculate the direction vector from one point to the other, and then compare it to a reference vector. What? What is the method to get the angle between two angle from one point to another window? Angle 2. Okay. A10 2. Okay. What you saying, Dottie? Yeah. Yeah, the problem is the rope could be facing the horizontal rope can be rotated around. Right, this is the horizontal rope, and when I'm putting horizontal ropes in the game, it could be facing like any direction around the y-axis. Right, it could be facing any direction around the y-axis. So I need the player, once the player interacts with it, I need them to actually like be snapped to the closest point on the rope and face that direction. Right now I'm just trying to figure out how to get them to snap to the closest point, which I'm getting close. Okay, so first I need to calculate direction 2, or distance 2. So here's the horizontal rope. We need like a var distance equals self dot global position dot distance 2 to rope position. Okay, so that is this distance 2. That's our D. And theta is going to be var direction position minus self dot global position, and then var angle equals, what is it, atan 2 negative direction dot x negative direction dot z. What is this doing? Returns the arctangent of xy in radians used to get the angle of tangent y over x. Compute the value. Okay, I might have to mess around with this, but that would be our theta. Multiply it by sine of that angle, we get x. Oh, okay. Cancel. So var x equals distance times sine of angle. Var z equals distance times cosine of that angle. And then, I mean, we'll try it, var, or no, self dot global position dot x equals x, and self dot global position dot z equals z. Maybe. Alright, not quite. Okay, so it seems to be putting us... Where's it putting us? Is it putting us on spawn point? I think it's just putting us on spawn, or is it putting us at the end of the rope? So the problem is to actually know the angle the rope is facing. Yeah, we don't know the rope is facing. Position of start, angle to the position of end. Let me move this rope and see what's going on. Move it like away from spawn, right here. Yeah, it seems to just be putting me back at spawn. That's strange. I think I'm calculating the angles wrong. What do I do? I don't know. I feel like I was onto something here. Alright, if this is where we are. this. To get the 3D angular difference between two specific directions or target points, use vector 3.angle2. Like the angle between your object's forward vector, no. Got the distance. Let's say the origin is here. This is player pose. And then this one here is the rope position. So this here is not actually XZ. This here would be I don't think this is gonna work what I'm doing here. I think I'm gonna have to look it up more. Let's pull up Gemini. Horizontal. line segment, okay. Starting the rope's global position and extending along its forward or side axis. To snap the player to the closest point, we need to find the scalar projection of the player's position onto the rope's direction vector, and then clamp that value so that the player doesn't snap past the ends of the rope. Get the rope's directions. Since the origin is at the start, the rope extends in a specific local direction, local x-axis or z-axis, we get its global direction vector. Let's say I should tell Gemini that the rope extends on its x-axis. Yeah. It's positive x-axis. So it has the global position of the rope, there's a mockingbird outside your window chirping really loudly. Shoot it. Throw something at it. What does a mockingbird even sound like? Since it extends along that positive x-axis, basis.x gives us the normalized global direction of that local x-axis. Our rope direction, rope.global transform that basis.x.normalized. Okay. Vector from the rope's origin to the player. Var to player vector 3 equals global position minus rope's start. Okay, right. Project the player's relative position onto the rope's direction line. Var distance along rope. Float equals 2 player dot. What is that? Roper. Okay, that's a new function. 2 player dot. Closest point, vector 3 equals rope start plus rotor times clamped distance. Rope start plus rope direction times clamped distance. Okay. Oh, dot is dot product. Okay, let me try this. Rope.global transform.basis.x.normalized. So we need to call it with we need to call it with what do we call it with? Okay, I need to give Gemini another prompt because I don't think they realized that the rope could be rotated. Let me try this again. Extends from origin along its positive x-axis. However, the rope could be rotated around the up y-axis up direction vector when in game, so that, for example, it could be extended along the global z-axis, x-axis, or somewhere in between. Let's try this. Because we're using the rope's basis, rope.globaltransform.basis.x, the code already counts for rotation automatically. In Godot, it knows basis contain its local axes transformed into global space. That's right. Okay. Right. If you rotate the rope 90 degrees around the y-axis so it points down the global z-axis, basis.x automatically updates to point down the global z-axis. Here's the complete robust solution that handles any y-axis rotation along with the logic for how you can let the player move along the rope once they are snapped. Okay. Rope length is on rope, recurrent rope. Okay. And rope movement and else. Okay. Use a grab button near the rope or continuously via detection zone. Func try to snap rope. Our closest point equals get closest point on rope. Rope. Func. Okay, right here. Rope start. Vector 3, rope.global position. Right. Rope dir. Rope.global transform.basis.x.normalized. Okay. So it's pretty much giving me the same thing. Global position minus rope start. Okay, so first thing I need to do is in here, I need to add a, what is it? Rope direction, rope, so global transform dot basis dot x dot normalized. Global transform dot basis dot x dot normalized. Another parameter to this function. And then in here we'll call this rope direction. Right here we'll call this rope dir. So we have the rope position and the rope direction. Okay. Position and its direction. Vector from the rope's origin to the player. Okay. Start. So that would be var direction equals self dot global position minus rope position. So that takes care of that. And then here, project the player's position onto the rope's direction line. Distance along rope, float to player dot rope dir. So distance along rope, okay. Var distance along rope equals direction dot the direction. Wait, no. The rope direction. Two player dot, right. Rope dir. Okay. Var clamped distance equals float. I don't think I need to clamp the distance. Return rope start plus rope direction times clamp distance. And that's the same thing here. So self.global position equals rope start or rope position plus the, okay, that makes sense, I think. So then we're gonna do self.global position equals distance along, wait. Equals the rope start, yeah. Plus roper times distance along rope. Equals rope position plus direction, no, rope direction times distance along rope. But I also want it to be, the Y to be, have an offset. So we'll keep this offset part. So minus equals offset. Let's see if this works. I hope it does. 'Cause I don't really know what to do if it doesn't. I think it worked. Now we just need to change the look vector. I think it worked. Let's go. Sweet. Okay, cool. One thing that I just have so much trouble grasping is the whole transform and basises and stuff. The transformation of this node in global space relative to the world contains and represents this node's global position, global rotation, and global scale. Basis. The basis of this transformation. What does that mean? It is composed by three axes: basis.x, basis.y, basis.z. Together these represent the translations: rotation, scale, and shear. Okay. Yeah, I just don't understand this stuff very well. This transform.basis. Like, that just does not make much sense to me. What's going on here? But anyway, we're calling this rope direction. And then I get the direction to the rope. Okay, so the direction from player position to the rope's position. Distance along rope is the dot product of the rope's x-axis, okay, and the direction. That makes sense. Returns the dot product of this vector and width. This can be used to compare the angle between two vectors. For example, this can be used to determine whether an enemy is facing the player. Okay. The dot product will be 0 for right angle. Yeah. Okay. And then the global position equals the rope position. So optical position equals rope position plus rope dir plus times distance along rope. Yep, okay. Then we do the offset stuff. Reset the Y position. All right, cool. So the position, check. Now I just need to get the player to rotate the skin to look along the rope. So we got it snapping to the rope fine. Now I need to look at the direction we want to be facing. Perfect. I just want it to turn 180 degrees when we go the other direction. Look at that. This is fun. This is gonna be fun, jumping from rope to rope. Oof. Boom. That's fun. It's really fun. Just gotta time it right. Nice. Alright, so we need to do skin.look at, I think just rope dir would work. Skin dot look at rope dir. Vector 3 dot up. True. I can just do like vector 3 dot up here, right? Vector 3 dot up. Is there vector 3 dot up? Yeah. Up unit vector. Okay, that's not working quite right. It's looking that way. It's looking towards the origin. else did this have? Handle rope movement. Did that. Current rope dot global transfer dot basis dot x normalized. Position plus equals times speed. Thank you, Gemini. I feel like it does a really good job of explaining things. Basis.x. Okay, well, if this is true, then why, if I do skin.look at rope dir, why is this looking towards the origin? Yeah, rotor, so that's the same thing. Global.transform.basis.x normalized. Look target vector 3 global position time plus rotor. Look target. Here, let's look at look target. Target equals global position plus rotor. Interesting. That didn't work. I feel like that's not gonna work either. Okay. Okay, so it's facing that X direction always. Okay. Getting close. Now, based on if the player is moving to the right or to the left. Or we can just say so when I move to the left, and if I look from this side it goes that way. Huh. Yeah, this is way more complicated than a vertical rope. But we're getting somewhere. Okay, so I have the position done. The look at is always going to be facing... Okay, you know what I need to test though? I need to test if I rotate this. Like so. What's going to happen here? Okay, awesome. Oh, wait. Then the movement is messed up though. So, okay, so I need to move the player along this rope direction as well. So that's gonna be in here. So velocity equals input dir times rope direction. So I need to multiply by the rope direction, I think, in here. So what would be the best way to do that? Damn, this functional is giving me a headache. So I think I need to have like a variable called Horizontal rope movement direction equals rotor. So I have to create that variable. Bar horizontal rope movement dir and this is a vector 3. So we set that here, and then I can use it in the state. So we get the input direction, velocity equals input direction times horizontal rope movement dir times climb speed. Should be a swing speed, which I want to be slightly faster, I think. Try this out. Awesome. So now we're moving along the rope, no matter which way it's rotated. Why is it multiplying by vector? The unit vector times this. Vectors are confusing. Right, so now if I go here and rotate the rope again, face it maybe this way, it should still work because it's being multiplied by the rope. Local x-axis. Let's try this out. Back onto it. Yep, okay. Okay, so that's done. Now I need to have the player skin flip around when I'm moving backwards. So do I like that speed? Does that speed look good? Or should I make it faster or slower, the swing speed? I think that looks good. I like that speed. So it's slightly faster than the climb speed, which makes sense, I think. Okay, so how to make the player flip around? Should I just do like a 180 turn? Oh, we could do another look at. Since I have the rope direction, the rope length direction stored in a global variable, I can just do another look at inside the swing state. Physics processing, so like if it's -1, just gonna call this horizontal rope. In direction. So like, if it's not equal to 0, and then we can say if input dir is equal to 1, or no, we don't even need to do that. We can just say skin dot look at horizontal rope movement dir vector 3 dot up true, so it's facing the correct way. So if it's not equal to 0, we move in that direction and we look at that direction. Might need to do like a global position plus again. Yeah. Global position plus horizontal rope movement dir for the look at. Okay, and if we go this, oof, it didn't turn around, dang it. Oh yeah, because if we turn around, it needs to be opposite, so I do need a conditional in there. Okay, so if input dir is equal to 1, so positive, it needs to be this. And then else skin dot look at just this. I don't need this part. Let's try that. Go this way, turn around, go this way. Look at that. We're turning. Okay. So one thing that's awkward is, wait, if I go on the rope this way, oops. Yeah, so when I'm moving this way, I'm pressing the left arrow. When I'm moving this way, I'm pressing the right arrow. But when I turn the camera this way, right arrow, left arrow. So last thing I need to figure out for this functionality is, if I move the camera to this side, is there a way I can change it so that when I press right arrow, it goes to the right, left arrow, it goes to the left? Because it works facing this way. This way, it doesn't. So I need to be able to somehow like store the rotation of the camera. Try moving this rope again. Let's rotate it like this. Yeah, so right now I'm pressing the right arrow and it's moving to the left. When I press the left arrow, it moves to the right. But then I flip the camera over here, I press right arrow, it goes in the right. And the left arrow goes to the left, so that's correct. But over here, it goes opposite. And that's hard to keep track of for the player. So I need to look into that, I think. This is all going to depend on like what direction the camera is. So this is the X. If the camera is... yeah, something with the camera. Alright, well, that's all I'm going to do on stream right now, so peace out. Till next time.